at Boeing have a real challenge. If we're to be successful in the future, we must do what other world-class companies around the world have done, and that is to provide our customers with more value at less cost. Our challenge will be to ensure that our customers prefer Boeing airplanes over those of our competitors. To do that means we must have reliable methods and processes, both in the factory and in the office. That is the reason for CQI, continuous quality improvement. And one of the methods that a lot of great companies have used are the 5 S's: sorting, simplifying, sweeping, standardizing, and self-discipline. World-class companies use these 5 S's as a way to organize their work, make it more effective and efficient and safer. Many Boeing organizations are already implementing the 5 S's with tremendous results. Less clutter in the workplace, improved safety on the job, improved reliability of machines and equipment, and improved employee morale and working relationships. Each one of us has to play a part in making that happen. If we do what we can with CQI and the 5 S's, we can affect the competitiveness of the Boeing company.
I won't stop the tape. Okay, it's more for training. So.
Initially, I thought the 5 S's were just another one of those things that we're going to do to make upper management happy.
The thought of working out of a community toolbox didn't seem possible.
And our feeling, or my feeling about it was, we don't have time to mess with this. We have a lot of parts to build and deadlines to meet.
I didn't have a good feeling about it. I felt it would just be a waste of my time. I just wanted to do my work, and I thought it was just going to be another program that would come and go.
Currently, I'm glad we got rid of the personal toolboxes, because now I see we don't need them. I have my shadow board, it has all the tools I need to do my job.
So we've had plenty of time to see that it actually does work. So we're pretty excited about it, and it's part of our everyday process now.
It makes our work easier. I can go home at night feeling that I've accomplished something rather than looking around for something all day long.
Now everything's very well organized, and it makes our jobs go much smoother.
These two groups of Boeing employees have been practicing the 5 S's for some time, and they're experiencing the results every day.
A quick comment on this. I'm not going to show you the second part of the video, which is about how 5S was applied in the office. Again, you will see that this is an old video. I mean, Gary Condit was the CEO of Boeing decades ago, and unfortunately, he had a not very good exit because apparently on his watch, there were cases of sexual harassment, and he did not, take action. So forget about that part. But again, in the office lean part of this video, they are talking about paperwork and folders, and you know for sure that IT has absolutely taken over the paperwork flow aspect. In fact, today's ERP systems claim to be paperless. And there is one of them that actually really comes through. It's called ProShop ERP, P-R-O-S-H-O-P ERP. And the website is adionsystems.com, A-D-I-O-N systems.com. Okay, so I'm going to only show you the assembly part, the manufacturing part of the 5S video, and then transition to the other videos on 5S and tooling management in job shops. Thank you.
What changed their initial opinions about the 5Ss, and what's happened to their work environments along the way? Well, both groups work inside this building, but their work areas and processes are very different. One's a manufacturing area, the other's an office environment. Now, in this video, we're going to find out about each group's experiences with the 5Ss. We'll see some of what they've accomplished, and we'll hear from them how their jobs have been affected. Now, just inside this door is the area where the main landing gear door is assembled for the 757. The area's employees started their 5S activities about a year and a half ago. Now, since then, their area has changed dramatically.
Before we implemented the 5Ss, our area was pretty much a mess. We didn't know it at that time, but we had workbenches that were serving as benches, tool storage, lunch tables. We were storing parts on them. Just about wherever we could put something, that's where it went.
The first step to making changes in the area was the first S, sorting.
It was actually a lot of fun. It was surprising in the end when we had sorted everything that we deemed unnecessary. The big pile of stuff we had in the middle of the floor was just amazing. We had 2 or 3 SA dollies full of stuff that was carted out of here that we had decided weren't really a necessary part of our process. It was really amazing.
In the beginning, it was hard to get rid of things, but when we looked at the reality of the issue, we had to decide, do we need it? And if we don't need it, we get rid of it. If we do need it, we need to decide how much of it we need to keep in the area, and we need to have a permanent location for it.
Okay, guys, the first thing we're going to do is the first step, sorting. And the way we'll get started in order to...
Sorting is not a one-time thing in this area. Several times since their initial sorting, they've repeated the process, and in doing so, have removed even more unnecessary stuff. The process starts with agreeing on sorting criteria and designating areas for small teams to tackle.
So this is important, the sorting criteria, and if I can read it correctly, basically what you're doing is you're looking at every item that is in the workspace you're trying to 5S, and you're looking at usage frequency at 3 levels. 1, use daily. 2, use weekly. 3, use occasionally. And of course, the 4th one is where none of these 3 criteria are filled. You basically say, hey, that seems to be junk, and you need to get rid of it. So, in the first S, very popular thing is called the red tag event, and that is where you set up tags, and these are available online now. 5S has been in use for decades. So the red tag basically dispositions the item, and you create one area where any item which did not fill these 3 criteria of usage essentially gets put in that area. And then people get to, take it home if they wish, and maybe a month later, all of that stuff is put in the dumpster or given for recycling. It's basically disposition, got rid of. But see, this is very important. And I think that if you are the industrial engineer tasked with continuous improvement, you have to lead the discussion, but not make the decisions. Let the people working in the area be the judge. You can guide, you can suggest, but it's like this, gentlemen, gentlewomen, please, these are all the things we've identified, and I would like you to decide as a group, show of hands, simple verbal voting, what is the status of usage of this particular item, okay? Daily, weekly, maybe, but for sure, but not immediately in the area of work. And of course, the 4th one is, yeah, this is junk. So please follow the conversation.
To use it at least weekly.
The team members touch every item in their assigned area and decide if it's really needed. If they think an item is not needed, it's tagged with a Post-it note and brought to a holding area.
Sounds good. I don't know what they are. Let's tag them and we'll find out. Okay, sounds good.
Later, the entire group reassembles and holds a sorting auction. Now, through the auction, they must reach agreement on whether the tagged items are indeed unnecessary.
Nobody uses it anymore. Oh, let's get rid of it.
Get rid of it?
Yeah, all right. Okay, we have 3 boxes of these bulbs. These are VG 10K42s. Who uses these?
We do.
Everybody does?
Yeah, we use them on the main landing gear doors.
On the main landing gear door?
Yeah.
How often do you use it?
We use them. We use a box up in a month probably.
Box in a month?
Yeah.
But you use them every day?
Yeah.
Well, what do you think? Think we ought to maybe take 1 box and leave it in the area and send the other 2 to surplus or to standards?
Yeah.
Okay, guys, for those of you who are taking the production planning and inventory control class, what they are verbalizing is essentially what we learn as basic inventory control models. Okay, so what do we do in inventory control? Okay, I have an item and I have a usage, I have a consumption rate, I have basically a reorder point when I should order stuff, and then I have a reorder quantity. And then I have a maximum inventory I wish to hold of this item. So if you go back into your production planning and control textbook, I use the one Sipper and Bulfin, wonderful book, applied and theoretical. Look at the way the inventory model is specified. There'll be a maximum inventory, a reorder point inventory, and the reorder point is managed in such a way that the lead time is buffered against. So if it takes X days to get the replenishment quantity, then that reorder point represents a certain amount of inventory, which will be consumption rate per day multiplied by the number of days it will take for replenishment, plus say a 10% safety factor. Okay, so that's essentially what they're doing. This verbalizing which they are doing is essentially a data-driven process for any industrial engineer.
We have consensus. Everybody agree with that? You working with it? Okay, great. Marty, I'd like you to take custody of this and find the proper location and properly identify those. Thank you. Want to take these? All right.
Every tagged item goes through these same sorting criteria questions. Those that meet the criteria and are deemed necessary by the group are ready for the next steps, simplifying.
Anybody use this?
Okay, so this is essentially a layout problem. Create and identify a place for everything. So to give you an example, go back to the Toast Kaizen video which you saw. Okay, it was a very simple production system called TOPS, Toast Production System, but wasn't the placement of items you needed at the time of use, at the location of use, in the quantity of use, at the point of use, right? That's essentially what the second S is all about. So what you learn in facilities planning is essentially kind of 5S, but 5S is like the practitioner's learning of facilities planning, and you who are using things like MCraft and Layopt and FAST and SCHEDI are kind of using the mathematical approach to essentially saying, well, there are all these items, there's a certain sequence and volume in which I use them. Here are the relationships between pairs of items. And so let me arrange them in such a way that if I did so many work processes and I touched the individual items so many times a day in this and that sequence as captured in the from-to chart, the total travel distance is minimized with this particular arrangement. You can apply that to workstation design. You can apply that to layout of a single cell. You can apply that to layout of the shipping department. It basically applies everywhere. So this is basically facilities planning.
Simplifying really means organizing and arranging everything that's needed so you can do the job efficiently and safely. The landing gear doors employees have created some excellent examples. They designed these mobile work tables for each of the door assembly tools. Attached to each table is a shadow board. It contains and organizes all the tools, drills, and bits they need to work.
So do you see mobile, or well, whatever, mobile, whichever way you pronounce it, mobile workstation. So it has the work surface, it has the tools, it has the parts, it has the gauges, and you can move the workstation to any and every location that you need. So mobility is a huge, aspect of modern factory design. I've even seen machine vendors basically saying this machine can be moved. So what they do is they stick like a inflatable balloon under the machine, and then they blow it up and poof, they literally can pull the machine to its next location. So please keep this in mind. Mobile workstation, something which can be moved, and see how well it is organized. If you see this outline, if the outline is exposed, it means somebody has taken the tool and needs to return it by the end of day before they go home. And if it is filled up, that is where the tool should be. But the condition of the tool should be as when it was taken away. You cannot put back a broken tool or a damaged tool. So now that is where the culture and the work ethic kicks in. People should not think, I don't care, I broke it, somebody else will replace it. No, the next person who finds this broken tool is going to get affected. So, that is where the team culture, kicks in. And again, best way to start creating a team culture is metrics and accountability. So that is where you have these 5S audits.
On the door in that position.
When I go to reach for a certain tool, a drill motor, a screw gun, or anything like that, it's right. I know exactly where it is. I don't have to search.
Another shadow board mounted on a cart holds the drill plates that get mounted on the door assembly tool. Some of these plates weigh over 40 pounds, but because of their arrangement on the shadow board, there's no more.
Do you see now? I don't know if you study ergonomics, but that's a very big area of industrial engineering study. And ergonomics is one of the areas, ergonomics and safety and conducive work environment is one of the areas where you win over the employees when they hear, oh my God, industrial engineers and management are going to come here and implement lean. Lean means less employees are needed. No. When you look at ergonomics, and do you see they've taken these fixtures and they've put holding handles. And this height at which the heaviest and the most used fixture is kept at is in the center of the board at the safe lifting height, kind of in the midriff. So keep in mind that 5S is also about safety and ergonomics. Okay?
Bending and twisting required to lift them into place on the tool. And the cart's mobility saves a lot of steps toward carrying a heavy load. Notice that labels on both the plate and the shadow board make it clear where the plate belongs. Outlines on the floor clearly tell you where things that can be moved should be located. Everything from mobile rack.
So do you see these are white markers, and this is the identification. This square is the location for such and such cart or workstation. That is how beautiful this method is if correctly done. If somebody is in training, they don't come in and ask, well, what am I supposed to put in this area? Right over here, there's a label, and that label will be painted in several places on this fixture.
For the doors to garbage cans and hazardous waste containers. And hazard stripes identify danger zones around equipment. Possibly the most significant change in the area is the disappearance of personal toolboxes. It's taken a while, but
And let me share with you why toolboxes are such a sticking point. My experience has been is that it's a two-pronged sword. Tools are typically purchased by the plant manager, right? And the plant manager reports to the director of manufacturing or the vice president of operations. If the plant manager sees that, his or her boss is cost conscious, that person is not gonna buy or agree to buying a company's own tools and gauges, right? And eliminating these toolboxes. So what ends up happening is the individual operators, like machinists, will say, my God, for me to do my job, I need fixtures, measuring devices, and other, instruments to make sure that the quality of my work is correct. If the management won't buy it, I'm going to buy it, right? Unfortunately, those gauges have to be calibrated by inspection. Now, when there's no accountability and when there is, personal tools and the calibration is not being done, that is exactly where you end up situations where parts are delivered to inspection and inspection says, sorry, this failed. So disappearing toolboxes and creating what I would call community tool boards is important. There are challenges also of maintaining that board, but the big thing here is that all of the gauges, all of the other instruments being used are basically standardized and managed and maintained and calibrated and tracked and recalibrated by the shop. That's the important part of disappearing these toolboxes. So in one of my very good client engagements, they basically designed a toolbox with a very formal allocation and layout of every drawer and the shadow board above the work surface. But they also said, look, if you wish, you can bring in a toolbox, but that toolbox cannot carry, tools that we aren't having. You have to tell us what tools we need, and we will make it a point to go and get them and calibrate them and give that to you. So that is the importance, really, of trying to get away with personal toolboxes.
One is taking their toolboxes home.
I don't have a toolbox anymore. I can go to any area in this shop and work without my toolbox. I don't need it. Except for specialty things, and that's what our drawer room's for.
To this area's employees, sweeping means something more than just pushing a broom. It includes an ongoing visual inspection of their work area.
When I sweep across my area and I notice something's out of place, I'll put it back in place. This is what keeps your area organized. So I visually sweep the area for anything that is out of place, including our shadow boards. If some motors are missing, they're usually on the bench somewhere. I'll grab them and put them back. This is something that I do throughout the day.
Of course, for a truly clean workplace, physical cleaning is also part of their sweeping routines.
The physical cleanup is a disciplined part of 5S, and you have to clean, you have to sweep.
Let me share with you several personal experiences I've had. I've, taken tours of many facilities, and what has been impressive about those facilities where I had a positive client engagement? When I was given a walk by their plant manager or their director of manufacturing, while walking, if they saw some, gum wrapper or some kind of plastic lying around in the material handling aisle, they stooped down, picked it up, rubbed it in, kept it in their hand, and they were like, well, I'll be talking later. We need to keep this place cleaner. That shows an attitude. Let me share with you a very positive experience with a client called Superior Completion Services. Once on the floor, I had got my safety glasses, kind of stuck on my head, and I've not pulled them down. I was in the shipping area where mainly assembly occurs, but the area supervisor walked up and said, please, would you put your safety glasses on? That is how well their safety director had ingrained the safety principle of 5S into their employees. Everybody had a right to pull up or advise or cajole their colleague because it was a company standard of safety.
By the way we have our area set up now, it's much easier. There's no clutter. It's not cluttered. There's not a lot of things around it on the floors or everywhere too. So the cleaning is real easy.
Since most of their equipment is on wheeled carts, the group can sweep and clean up more efficiently and thoroughly.
It's an ongoing thing. You can't just say, well, we clean up 15 minutes at the end of the shift. We don't do that. It's ongoing, always.
Standardizing means having a specific process that everyone follows. No variation.
Remember that Toast Kaizen, one of the assessments that we had for the course, which I think till now probably only one team has done. Okay, because I think it's an okay job and it's not their fault. I think I misled them that the EVSN software has a good template. I don't think it's very good. But standard work instructions, even for making toast, right? Basically, you design the toast making process in such a way that it had the least number of steps with the least amount of quality problems and the least amount of labor content, right? Same thing. This is standard work instruction. Why? At a certain point, any and everybody can be trained to do a particular job in a certain way. And if you attach videos online in a local server, then training can be done asynchronously. But the beauty here is that safety is taken care of, quality is taken care of, cycle time is taken care of. Why? Because there's a standard process being adopted. Okay, that's very important. And you can see how heavy this particular part is, right? So it's a two-person job, crane or a hoist assisted, and on that table, there'll be markings which will guide them which part of the part should be aligned to which location before they take off the straps and fixture the part.
Process can change later, but for the time being, everyone sticks to a specific process. That's standardizing.
To assemble the main landing gear door, the mechanics use many different sized fasteners. The group has standardized the order in which boxes of fasteners or...
So do you see, for those of you who especially are mechanical engineers and are familiar with something called design for assembly, this is one of the big areas. Designers who sit in the office and don't talk to shop employees, they pretty much just, oh, for this design, let me pick this fastener. Material is different, threading is different, tensile strength is different. And over time, even for such basic items, there's so much cost upfront to purchase and hold so much inventory of each item and put reorder point labels, right? And pay for a minimum buy quantity. Just for little items, forget about the high-end items, right? So I think that when you standardize, you even come back and say, do I really need so many fasteners? And you can apply that thinking process to hardware items across the board. You can even apply that to bar stock, raw material sizes across the board, to tooling inserts. So standardization essentially is going to impact how much time and money and material you waste because of the changeover from one type of item to another type of item.
Ranged on a mobile cart. This order matches the standardized sequence in which they install the fasteners in the door. Another example of standardizing are the shadow boards for the two door assembly tools. There are shadow boards for both the left and the right doors. The crew designed the layouts for these shadow boards to be identical. This standardization eliminates searching for tools when switching from work on one.
You see that? Searching for tools. So much time, when you look at setup time, so much time is lost to find the tools, check the tools. If they're heavy, to go look for a cart, to bring the tools, and then to essentially use them on the machine. So this is not trivial. This is not trivial. But again, this kind of arrangement and rationalizing what you will need in what sizes has to absolutely be done with the employees. And you as the industrial engineer, you can be just a bystander or a team member. Don't try and lead it. Let them have the full say as far as designing such shadow boards.
Door to the other. As an outgrowth of their 5S activities, the group has also begun to standardize some of their work processes.
In the past, before the 5Ss, we used to put tools or do our processes in any open space that we had on the floor. Doing the 5Ss has really organized us. We now do our process flow. Our incoming comes in, it's identified, it goes straight into our tools, out of our tools, onto the floor to do the floor work, into seal.
What shape of the alphabet is this? U, correct? You see, in assembly, the U shape makes complete sense. You take something, a line, which had this length, and you almost split it into a third each, 1/3, 1/3, 1/3. Inside is where people work. Outside is the logistics. That's pretty much why U layouts are so popular. for most work cell arrangements.
The paint, it's almost like a horseshoe effect.
It is not easy to be self-disciplined in the 5S program. It's something that you grow into. It doesn't become natural, but it becomes habit. The longer you work at it, the better you become at being self-disciplined.
Self-discipline is just something that you have to have if it's going to work.
In our case, on the FHAs here, if you run out of a certain size of a drill bit, the self-discipline kicks in when you go and you replenish that drill bit supply instead of just sneaking over to the other FHA and stealing one of their drill bits or something like that.
But self-discipline goes.
Watch this portion. You know, this is what is essentially layout done at the workstation level. So the whole challenge is I have so many tools and I need to find locations for all the tools. In this case, they have what is called a functional layout. So that means, see, all tools of the same type are going to be arranged by size in one area. I don't agree. I think that there are situations where, especially in maintenance and repair facilities, they've actually created toolkits, and they have these tool bags hung on the walls, and there are labels. For this task, pull this toolkit. For this task, pull this toolkit. People just walk up and they pull that bag and they walk to the site because that's the task they wish to do. So again, a lot of this is videotaping, and you can see again people are working, but everybody gives input and saying why? Because hey, when I do the work, this is how I use various combinations of tools. So it's a very 5S Shadow Board is a very team-oriented, analysis-oriented activity.
Beyond the individual, the group has learned that they must work at the 5S's as a team. This includes getting input from everyone who could be affected by a 5S improvement.
Everyone has to participate in 5S. It isn't a one-person thing. It's a group effort. And without the group, you're done.
The group has also learned that their management must play a supportive role, especially when planning for initial 5S implementation. Ray Bracey, General Supervisor for the building, agrees.
In terms of being leaders, it doesn't mean going out and doing it ourselves. It means asking people how they want it done and then giving them the resources to allow it to occur, whether that's things like shadow boards that we have in the shop floor or tools or what have you, or whether it's time or whether it's money to make things happen.
It's fairly easy to see how much the landing gear door area has benefited from the 5S's. But
okay, so that's the first video. Would there be any questions? Any questions? Okay, let me play the next video then. These two videos are organizing tools in machine shops. So all machine shops are job shops. There are tremendous variety and combinations of tools being used. And so I want you to again watch. There are two parts. One is introduction and the other one is case studies. So again, I'll do my best to keep my mouth shut, but you know me by now.
Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program is an introduction to lean tooling and shows you how it's used to cut costs, reduce lead time, and improve quality. Many companies are turning to lean manufacturing to reach the high performance output their customers demand. Regardless of what type of manufacturing you do, machines and tooling play a critical role in your business performance. The basic thinking behind lean manufacturing programs is the elimination of waste. Much of this waste is caused by the poor management of tooling, inserts, clamps, and gauges. Lean manufacturing defines 7 wastes that are so costly, they're known as the 7 deadly wastes. They include searching and waiting, transport, excess inventory, overproduction, overprocessing, unnecessary motion, and defects. Lean tooling helps eliminate these 7 deadly wastes.
You can waste a lot of time during the hunt and search. So I said that's the main part. If you're going to have throughput, you don't want people leaving the cell. You don't want to waste time looking for things. You want to make sure if a tool, if it's easy to find, it's also easy to keep track of and make sure that it's in the proper repair. So when you go to use it, it's ready to go. So you minimize scrap, minimize lost time searching, and you can satisfy the customer.
Lean tooling has 2 primary goals. The first is to have any tool in the hands of the person who needs it within 30 seconds. The second goal is to have any tool operational in less than 10 minutes from the beginning of the setup. An effective way to implement lean tooling is by following a 5-phase plan. Phase 1 prepares the project by creating a clear vision of your goals, getting management support, and forming a strong cross-functional team. Phase 2 studies and measures the problem, so there's an in-depth understanding of all the issues, obstacles, and barriers. In Phase 3, before attacking any tooling problems directly, you must remove many of the generic workplace problems that you'll confront by applying the 5S system for workplace organization. In Phase 4, you will standardize tooling activities at the point of use and throughout the plant. You will create new designs for tool storage and management, and implement visual displays and controls. Finally, in Phase 5, you will implement a plan to stabilize tooling and sustain your gains through audits and problem-solving methods. Three activities occur in Phase 1: getting management involvement, identifying target areas, and forming a core implementation team. The most important of these activities is getting management involvement. The Lean Tooling Workbook has a list of 10 management issues you can use to rate management involvement. The best way to use this list is to complete it as a group so everyone can evaluate the management commitment.
Unless the workers see management support, that they have upper management directly participating in their teams and supporting their decisions and helping fund the projects to keep them driving, they feel that it's just going to be another flavor of the day.
To get started with lean tooling, it is best to select various target areas for improvement and then prioritize them. Each area should have an assigned champion who has time available for these improvements. But to be totally successful with a lean tooling program, it must eventually be implemented throughout the entire plant. As an example, this plant chose to perform lean tooling on most of its machine cells first. Then it moved the tool cage to the center of the factory, changed the layout, and started a Kanban system to control tooling inventory. Their next step was to organize the quality department and remaining cells. Well-planned changes allowed this company to get the most return for its investment and convinced skeptical managers and employees alike of the need for a total lean tooling transformation. Teamwork is crucial to making lean tooling successful. Lean tooling teams must include the right people. Team members must have the proper authority and the resources to make changes. Members must understand how the company generates profits and how lean tooling affects the bottom line. Each team must also include frontline people who are closest to the details. Occasionally, a team may have extended members outside of the production workforce from the engineering or design staff. Now the team is ready to study and measure tooling in the target area. Phase 2 begins with selecting a way to measure the current productivity of your tooling. Methods such as photography, a diagnostic checklist, a target statement, and a project storyboard can be used to measure your current state. But the focus of Phase 2 is on measures. Begin your measurements by looking at the two basic goals of lean tooling. The first goal is to have any tool in your plant in the hands of the person who needs it within 30 seconds. So, your first measure is how long it takes to get tools into the hands of the person who needs them. The second goal is to have any tool operational in less than 10 minutes from the beginning of setup. So the second measure is setup time. Setup time is measured from the time you made the last good part to the time you make the next good part. Anything in between is wasted machine time. Another good measure is the percentage of total revenue you spend on perishable tooling. Of course, to really study the measures,
I just wanted to interrupt here to stress a point. You know, tooling, when you look at machine shop supplies, between tools and coolant and fixtures, whatever, I've heard that the total cost could be in the 300,000, 400,000 area. Really significant. And that's just the material purchase cost. You won't be able to believe how much downtime exists when they have a simple blooper. So what they have is a tool crib in the one corner of the shop, and they buy inserts. Okay, so they buy inserts, drills, boring bars, etc., and they keep them in a corner of the shop. And this is the so-called common tooling. Now, individual machinists need inserts. So guess what? They leave their machine and they walk to this particular tool crib. They start looking for those inserts, and the inserts have not been organized. Right? They're basically in drawers and no count whatsoever. Say they don't find the insert. Now they say, well, I run this machine. There are identical machines like the type I run in other areas. Now they start walking around the shop and they go asking each machinist, hey, can I get 2 of your inserts? Many times, the other person will say, hell no. And they'll brandish like a big box of inserts and say, well, I got this box, it was the last box, and I'm going to keep it because if my machine goes down, my productivity and efficiency count will be reduced and management will beat me up. In the meantime, what was this guy's machine doing? Nothing. So I know it's kind of an area by itself, but replenishment and management of consumable tooling is a massive, massive area of opportunity. Most vendors now sell these automatic vending machines. And those vending machines are essentially inventory control boxes. And now you have to be in charge to collect the data, look at tool life, tool usage, machinist expertise, and then determine how much safety stock and how much maximum quantity you should have for each of these tools. But it's a massive, just consumable tools is a massive area of cost reduction.
Have to stratify them or break them into smaller amounts.
So it's easy to quantify the hard cost of what the tooling is. It's difficult oftentimes to look at the impact of the cost, what it takes if you can't find it, or what's it cost you if it's not in good repair when you go to use it. Is the tool there when I need it? Okay. Is it ready to go? If it's not, what was wrong with it? Was it lost? Was it misplaced? Was it broken? Then we try to capture those costs. So what we're trying to build is really a database of what that really does cost us when tools aren't in the right place, when they aren't ready to go.
Before making any changes, take photographs of the current state. These pictures can provide visual details to measure existing conditions in the target area. While taking photographs, you can also apply the Lean Tooling Diagnostic Checklist. By rating your target area in all of the 5 areas, you will gain an in-depth understanding of your current state of tooling and a clear list of where improvements are needed. In most cases, This in-depth examination exposes problems few people knew about. So now it's time to bring it all together into one target statement. The purpose of this target statement is to explain exactly what the team is supposed to achieve and how they will measure it. It should be written in simple language. A good target statement also tells us the current rate, target rate, and why it is important to meet the target. In phase 2, you've created a focus for lean tooling and developed an understanding of the waste that is present. Now it's time to begin improvement. Before attacking tooling directly, you need to clean and organize the work area following the 5S system. This will prepare the area for tooling improvements. The 5S system consists of 5 activities with names that begin with the letter S. They stand for sort, set in order, shine, standardize, and sustain. Sort involves sorting through the contents of an area and immediately removing unnecessary items to a holding area. This includes large items such as old equipment and small items in drawers and cabinets. The rule for sort is, when in doubt, move it out. Set in order involves arranging items for easy and efficient access and use. There should be a place for everything, and everything should be in its place. Shine means cleaning everything and keeping it clean. The essence of shine is inspection through cleaning. Standardize involves creating guidelines for keeping the area organized, efficient, and clean. This includes visual controls such as lines, labels, signs, and color coding. Sustain involves communication and education to ensure that everyone follows the 5S standards. In phase 4, you'll draw an area map to understand how your current tooling standards operate. You'll create new standard operating procedures for tooling, bring order to the point of use tooling, and redesign the workplace to support new standards.
Guys, go back to the toast Kaizen. I know it was only a question of, they're just making a slice of toast. But if you look at these steps, draw the spaghetti diagram, create the standard operating procedure. Remember, that was the future state flow process chart. Bring order to point of use tooling. All the tools needed, all the materials needed were at the point where he buttered the slice of toast when it came off the toaster. And then you redesign the workplace to suit that particular workflow. What you did with the toast Kaizen is basically now applicable to just about any workplace where material is physical. Now, if you were organizing an IT system, I don't know much about that, but again, in an IT system, instead of machined parts, you've got documents, decisions, and data elements being transferred. Same thing. You just have to create a spaghetti diagram and then organize which server, which database, which app will have the appropriate items of information.
Then you'll implement visual controls to reinforce the standards and the new design. The area map shows the position of all items and workstations in the target area, especially tools and tooling. The arrow diagram is drawn on the area map to show the flow of all activity. As you draw your arrow diagram, pay close attention to where tools are used, delivered, stored, maintained, or reordered, and the routes that are traveled between these activities. Later, when you redesign the workplace, you'll draw a proposed diagram to replace the current state. Now it's time to create new tooling standards. New tooling standards determine the best and easiest way to perform tooling activities. They also provide a foundation for new employee training. For lean tooling, every activity must have a standard operational procedure. The best place to start when creating standards for tooling is at the point of use. Tools and tooling are managed differently than raw materials and finished parts. Tooling needs a standard way to be returned after use. In addition, Standards are needed for how tools are sent out.
I want to sound some words of caution to you. Be a little careful about not getting too drawn into, ooh, shadow boards, shadow boards. If you notice, many shadow boards tend to be designed for those cheap, hand tool type of items. You saw that whole storage area for raw material, all the bar stock, so horribly organized. Believe me, when you look at exotic materials and when you buy in bulk and then as you cut the raw material piece from say 30 feet and now you have drop pieces, drop losses, if you aren't smart about organizing those leftover pieces and reusing them for future jobs, and you end up throwing away that as basically scrap, along with all the chips coming off different machines. God forbid you are going to lose thousands in just unnecessary buying and storing and carrying cost of raw materials. So 5S, think about 5S not so much for the little, screwdrivers and pliers and little shadow boards, but the storage and accountability and traceability of expensive tools. So especially modern day machines, milling machines, boring machines, those are very expensive. I've heard a single boring bar from Sandvik could cost about $15,000 to the typical machine shop. And raw material storage, oh my God, I can't even begin to tell you how much merit there is to really go in and learn warehousing methodology and integrate that with 5S and visual management to design a new warehouse. So again, Google Lean Warehouse, Google Lean in machine shops, and you will find a lot of useful information.
Up to be repaired or sharpened. There are 5 simple steps that will bring you better control over your tools at the point of use. The first step is to remove all the tools from their point of use and return only what you need. And when you do return them, store them in logical groups so they can be easily located and replaced. Next, create visual controls so tools can be located and returned quickly. Clear labels and color coding will help you find what is needed faster. The third step is to make the point of use design so simple that the worker knows it by heart. Other methods include putting tools in the order of procedure or enlarging dimensions so tools are easy to grab. The fourth step for point of use control is to install retractable tooling. The fifth step is the elimination of tooling. At this level, you try to eliminate the need for a tool entirely. You will often see elimination employed in setups where much of the work is performed prior to shutdown, therefore eliminating the need for any point-of-use tooling. Lean tooling requires a new way of looking at things. One issue to consider is eliminating personal toolboxes to free up floor space. Since many tooling activities happen away from the point of use, designing efficient methods to move tooling is important. The first method is...
Let me add a little bit here. Why? Because they've shown a person pulling a tool cart. Google the term water spider. So the water spider is essentially a shop logistics person. And some of the best people that you can have is, take some of your best machinists and convert them into supervisory / water spider roles. Why? Because as a supervisor, you are assigning jobs to different machines. Also, the supervisor, you are having one person oversight on the tools and gauges and inserts being collected for a particular job. So now what happens is that machinists stay at their machines. And I've heard that fully burdened rates for machinists could be anywhere from $80 to $120. Now, when you look at a basic machine shop of 20 machines, and the machinists are going around trying to get the tools and things, that's a lot of downtime on the machines, as well as payroll paid for non-value added work. And that lost time is then made up through overtime over the weekends. That's a lot of money being lost. So this person, the water spider, I think is a very important logistical role that most machine shops may or may not implement. I personally, that's the first thing I try and do. I implement work cells, and I try to do the supplying of the work cells everything from bringing parts to rolling away parts, tools, coolant, instructions, first article inspection, everything. I try to ask, gentlemen, can we bring a couple of water spiders on every shift to operate the shop? So that role is very important. There's not much out there in the literature. Concept is pretty easy. The bigger deal is finding a person to do that kind of work, because a lot of skills are needed, and then being able to understand, well, what are the job priorities during the 8-hour shift? How does this person know what to do when, where? Those are some challenges.
It's tools on wheels. Regardless of the size of your plant or its tooling, you'll need to deliver some tools to the point of use at exactly the right time and in good condition. Since lean manufacturing means lower runs and more changeovers, it also means more activity with your tooling. And that means you need efficient delivery. Another effective method is a tooling supermarket to decentralize tools and make them easy to locate and return.
A lot of the assembly tools were in various locations and you weren't sure what cabinet they were in, where they were located. We've since taken these central stores and put them in numerical order and identified all the tools and individual locations in the door so they're easier access.
Another design strategy is to make job boxes or kits of tooling.
What we have here is a job box that we prepare for special tooling. We keep these in a designated area, so the next time the job comes up, we can pull it off the shelf and hopefully have most of the tooling that we need for the job.
But perhaps the largest design issue is the tool room or tool crib layout and location. Each plant has to decide whether it needs a tool crib at all, and if so, where it should be located and how it should be laid out. If you decide to have a tool crib, the rule for its layout should be easy access and easy use.
Let me share with you a little experience, a little example. You saw what the gentleman was handling, right? That little thing is called a tool holder. And that tool holder basically has a shank. It has the insert itself. It has some shims to kind of close the gap, and has a tightening screw. So a simple turning tool could consist of at least 5 individual pieces. So guess what happened, at least with this client, when we first started to look at management of tools. In the tool crib, they would have these boring bars. And the condition of the bar could be good to go, or it could be like broken bar. In many cases, you know what would have happened? That machinists would have come in, looked in the drawers to get a particular insert. Not finding that, they would go look in the boring bar rack, and then they would steal, basically, pirate those inserts. So now when the next person came looking for a complete tool, guess what? They had everything but the insert in it, and then they went little Bo Peep looking for a sheep around the shop to get that insert. So 5S is a lot about, control and quality and, cost management.
New standards at redesign won't work without continued long-term control. That's the purpose of visual control.
That's a scheduling board.
Time wasted looking for tools, tooling, or information can be eliminated with effective visual controls.
Do you see how much they have used videos? So, today the technology is much more superior, right? You've got GoPros, you've got smartphones, but at the end of the day, videotaping physical workflow, videotaping the physical workflow, and then sitting back with the people who were working in the area where you created the video and asking them, giving them examples of what is wasted time, the 7 forms of waste, and then saying, now could you please go and tell us about all the wastes and why those wastes are occurring, creating all those charts which we have been discussing, right? The flow process chart, the spaghetti diagram, the 5 whys, the 5 hows, the Gantt charts, the swim lane diagrams. All of those charts in one way or the other are documentations and measurements of the basic process that the video captures once for all. So once you have the video, now what you do is for every time you make an improvement in the area, you create another video. And then over time, you can boast to employees and visitors and customers, look, we went from this and 6 months later, this is where we are. come back next time and this is where we will be. So videotaping essentially, if done diplomatically and politely and ethically, still remains the best way that you can record a workflow or a system and then undertake improvement. So that's why I've been harping a lot on that Toast Kaizen video, and then the Toast value stream mapping video, and then expecting you guys to do more homework to look at analyzing videos online, because you've got to really become master at just being able to walk into an area and be able to say, whoa, I see $25,000 of opportunity. Whoa, I see $15,000 of opportunity. If you have that ability, trust me, you'll be very desirable as an industrial engineer.
Visual controls begin with lines, labels, and signs. The sign makes it clear where tools are to be delivered. Color coding is another effective visual control. At the tool crib, there are racks to match each cell. Another type of visual control is an andon or signal system. But perhaps the most powerful tooling for visual control is Kanban. With perishable tools, Kanban keeps tooling levels at standard minimum and maximum levels because it provides an easy method to reorder when tools reach minimum levels. With non-perishable tools, Kanban cards are used to run an in-house pull system for tooling repair and maintenance. You're now about ready to wrap up your lean tooling project and make sure you can maintain your gains. And that's the purpose of Phase 5. In Phase 5, lean tooling is no longer a project. It becomes part of everyday work. So, to ensure that you maintain your lean tooling focus and standards, you should perform quarterly audits and continue to work on ways to eliminate waste in tools and tooling. Every company is unique. However, regardless of your size, type of product, or tooling, there are 4 lean tooling keys that remain constant. The first key is measurement. Make sure you choose your measurement carefully. Continue to measure and post the results for everyone to see. Measurement brings focus. The second key is a no-blame environment. Remember that it is the system that is at fault, not the people. A no-blame environment brings participation, energy, and buy-in. The third key is the 5S system. The 5S is a way of thinking. The 5S system brings lean thinking to the shop floor every day. And the fourth key, the one that ties it all together, is teamwork. Teamwork brings all the necessary...
So going back again to something which we learned, and I hope to discuss it again. Remember the work cell video, customer-focused manufacturing? So if you were saying, well, teamwork is the way to be able to go about and create a certain work ethic and a certain attitude among people to implement 5S, to look at tooling management in a systematic way, then what you have to do is to build the team around the value stream. Go back to what the value stream is. It's a visual representation of the material flow, the production control information flow, and the measurement of a product family. So what does the work cell do? The work cell is designed to, as much as possible, be in charge of producing from raw material intake to finished product output of a family of products. So again, that's what I push, that wherever you can, if you can create work cells and to each work cell you assign a product family, then you can basically apply these 4 principles to get the best of teamwork. So you have value stream focus, you have teamwork, and you have accountability that management can impose on a particular team rather than saying, oh, you know what, everybody who works in the late department is a goofball, right? So that's what I think is very important. The concept of the value stream, product family, measurements, accountability, and then all these improvement activities.
Necessary knowledge and skills together.
You have to set a focus, you have to try it, you have to put a goal out there to try it, and we just wouldn't go back.
Good. Let me now finish off with the last video. So this is lean tooling in action. Again, I'm sorry, you know, in a typical classroom environment, we would have taken a break and you'd have chatted and you would have talked to your friends. I know that that's the downside of remote learning. But what I will do is I will basically take this video, and as before, I'll try. It takes half a day to do it. I'll try to post this on Blackboard, but I'll also try and post it on the Vimeo website so that you can access it from 4 directions. Okay, thank you. Let's go.
Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program shows lean tooling in action. You will see how companies are getting the right tool at the right time. At Lee Blake Precision Machining, a supplier of parts for aerospace, automotive, and medical industries, where they've integrated lean tooling into their daily work practices, saving a tremendous amount of time and money. At Eaton Aerospace, Aeroquip Fluid Conveyance Division, who manufacture fluid conveyance components for the aerospace industry. Eaton's improvements are based on visual controls, lean tooling, and good 5S practices. At K&A Machine and Tool, a supplier of precision machined components for the aerospace industry, where a Kanban tool management system has increased machine capacity and lowered costs. And at Classic Turning, a supplier of precision machined components, where employees are solving tooling and changeover problems through teamwork and continuous improvement. Lean tooling has 2 primary goals. The first is to have any tool in your plant in the hands of the person who needs it in under 30 seconds. The second goal is to have any tool operational in less than 10 minutes from the beginning of setup. The results of these 2 goals include faster throughput, higher capacity, lower costs, and greater customer satisfaction. But to accomplish lean tooling, your company has to demonstrate self-discipline while answering yes to some tough questions. Are tools always where they are needed, when they are needed, so there's no searching and waiting? Are your tools ready to use with all of their parts in place so that setup time is minimized? Do all tools work correctly so that there's no rework and as little scrap as possible? Can you rely on your tools for precision so that inspection time can be minimized or even eliminated? Do you know exactly when it's time to replace your tooling so that production goals are met and just-in-case inventory can be eliminated? Do you inspect tools as you clean them so that you can catch problems before they happen? Have you reduced the administrative costs of tooling management? Do you track these administrative costs? A good lean tooling program eliminates all this unnecessary time and expense from the chaotic use of tools and tooling. Lean tooling is a necessary part of your manufacturing program, one that brings immediate and powerful results. Lean tooling promotes a workplace where people want to participate and learn because it deals with the tools that people handle every day. When people practice lean tooling, they begin to feel like they can control the work, so the work doesn't control them. Lee Blake Precision Machining in Jackson, Michigan is a supplier of parts for the aerospace, automotive, and medical industries. At Lee Blake, lean tooling has become integrated into the overall manufacturing process. It begins with serving the customer on time.
If we didn't have well-organized tooling, if we didn't know what our tooling stack was, what its abilities were, and have it all either decentralized at the cells or in our organized central hub where we send it out to the cells, we wouldn't be able to respond.
At Lee Blake, lean tooling fits in with the workplace culture.
And I think that unless the workers see management support, that they have upper management directly participating in their teams and supporting their decisions and helping fund the projects to keep them driving, they feel that it's just going to be another flavor of the day.
At Lee Blake, lean tooling is built into every step of the production process. After the front office creates a new process router for each job, it is brought to the production office where 3 Kanban cards are written. These cards trigger activity throughout the plant. One card is delivered to the materials department so that appropriate materials can be prepared for the job. The second card is delivered to the quality department so they can locate the correct gauges for the job. After the gauges are boxed, the same card is used to identify them for the setup team. But the primary card is posted on the production board to trigger production and tooling activity. The production board is a visual map of the shop floor. Each job is assigned to a specific cell. Once a job is assigned, everyone knows what tooling will be needed and when. The production board alerts the setup teams to gather tooling, gauges, materials, and download CNC programs to the cells before the machines finish the last job. But lean tooling could not function unless the plant was first cleaned, organized, and standardized.
This tool crib we built from scratch, and we just painted a blank area, put up a crib, and then our old crib was located in the far corner of the plant. And it was a catch-all for everything. It had maintenance supplies, lawn supplies, brooms, mops, oil, dams, mixed in with all the perishable tooling. And wherever a spot was, that's where it got put. And we actually threw out probably over half of our old tooling that was in there. And this crib is only about half the size of our old one. We left the aisles open just enough to get a cart down, much like in the supermarket. And we kitted all of our spare parts into boxes and organized our tooling by its function. And we would have it all preset and ready to go. That way, all they have to do is they come in and they have their tooling list and they'll pick it out and put it in the cart.
Before lean tooling, there were no standards for which tools were to be kept within the cells. Now, only the necessary tooling is kept at each cell. Cells are now kept.
I'm sorry I missed that particular spot, but you saw the drawer with plastic cubbies, and there were free inserts in each cubby. Imagine that entire manual system, the item location, having 2 partitions in each container. So the front partition of that cubby hole contains loose inserts. That's bin 1. And behind that, the second partition contains the safety stock. Some more inserts, which until the next replenishment is done, those inserts will be in bin 2, they'll be pulled out and put in bin 1, and then the Kanban card will be acting as a trigger to say, please bring so many more inserts of this particular type and replenish this location, right? That entire manual process today has been replaced by automated vending machines. So, you can just Google vending machines for tooling, consumable tooling, and you will find there are at least 3 or 4 of these vendors. Kennametal does it. They not only make the tools, but they even sell the machines which do the replenishment. Now, the challenge I've heard is that consumable toolings, which is one way, people go in, they pull the inserts, they never bring it back. If an insert breaks or gets worn out, it's pretty much recycled, right? That's what's called consumable. The reusable tooling, the big milling cutters, the boring bars, the big gauges, those which have to be pulled, you have to associate the person who pulled it, then they have to be brought back. You have to make sure that it was returned in good condition, and then you maintain the inventory so that the next person that comes in again pulls it, takes away for use and brings it back. Reusable tooling, I believe, still remains a challenge. And the solutions they have are pretty sophisticated, RFID controlled, sealed tool cribs. I don't know today what is the state of the art for managing reusable tools. But you've heard of automated storage retrieval systems, like the ones you see in Walmart, those big orange boxes where you buy something and then it is stored in that ASRS, automated storage retrieval system. It's also called a vertical lift module. Maybe something like that could be used, but that's a pretty heavy investment, and small companies may not be able to use it. But going back, that whole manual process of managing tooling has been completely automated. And again, if today you go and get a data science minor, trust me, the data analysis you can do on the data coming off of the machines or the data coming off of those vending machines, you could have a tremendous impact on any manufacturer. So once again, I know times are tough, but what I say is learn, master, pick up these other skills, especially if you can leverage the operations research which you're already learning, the design of experiments which you're already learning, and get like a data science minor. It's not a buzzword. I think that the industrial engineer has so many areas of data analysis that it will be boggling to you as to how little time you have to implement that knowledge. So get a data science minor, guys. Don't let the current times get you down.
Kept clean and organized, and there is a designated place for everything.
We also developed a Kanban system that was quite simple to use to track our inserts and other perishable tooling, so we no longer had stockouts. Each drawer contains a Kanban tag like this, and when they take the last box or the last 5 inserts out, and there's only 5 left, they take this simple tag and put it in a bin right here. That signals our maintenance person that he'll come around once a day and collect those tags, that needs to be reordered.
Other visual controls have spread from the tool crib to the cells to reduce changeover times. To alert the setup person, a flag is raised 30 minutes before a job is completed. This time is used to gather gauges, stock, and the right tools just in time for setup. So 5S, visual controls, quick setup, and Kanban are all tools that have contributed to the success of lean tooling at Lee Blake. But to figure out what they needed to change was difficult. To help them find waste, Lee Blake is mapping the current state of the gauge storage area.
We went back and did a visual scan and took pictures of various messes and disorganization and bottlenecks that were happening. And then we mapped out, did a rough drawing of the whole department. We started putting up.
So again, you see how fabulous is their work. They not only have a layout of the area, but they've taken photographs of individual points. So if you were looking at what you could do to make your final project presentations really valuable, when you draw the spaghetti diagram and you are putting bubbles to represent each location where work is getting done, what you should also do is you should take a photograph and then put a hyperlink on that main spaghetti diagram, where if somebody clicks on that hyperlink, then in the back of the presentation there's a photograph, and on that slide you have described all the 7 forms of waste and other shortcomings of that area. But this is a wonderful template. Again, please guys, don't get tensed, don't get stressed out. I'm not saying that, even though you're working remotely, you should get all that information from your project sponsor today when you have only 3 weeks left to the semester. Please, don't get tense. All I'm getting at is that you have to really become good at collecting data and presenting data so that people can see in one slide or one presentation a complete walkthrough of a production system. Okay, so please don't get stressed out.
Pictures of the problem areas to highlight what a lot of the problem was. And most of the workers were very amazed how messy it really was. And then we started doing arrow diagrams to chart what our flow of activity was. And we saw that there was a lot of wasted motion, a lot of waiting and looking going on.
Before lean tooling, Lee Blake spent 5% of its total revenue on perishable tooling. After lean tooling, it has lowered this expense to 2.5%.
Even though we're using more expensive technology than ever before, our tooling costs continue to decrease because we're more aware of what's happening with our tooling. We're more aware of how much we're using, and we're more aware of what it's doing, what our ideal speeds and feeds are.
Eaton Aerospace Aeroquick Fluid Conveyance Division in Jackson, Michigan, has turned lean tooling into a science by using the principles of 5S, visual controls, and just-in-time. Eaton plants have thousands of different tooling components, and they needed help controlling each component. Joe Adams, an Eaton plant manager, explains the issue.
We have literally hundreds of tools to keep track of. So having a system that's easy, visual to maintain is critical, not only to make sure we have the right tool at the right time, obviously for throughput issues, but also maintain our overall costs of wasted time, motion, and searching and looking for tools.
But when Eaton began its lean tooling project in 1994, it was clear that some aspects of tooling had been neglected.
Is the tool there when I need it? Okay. Is it ready to go? If it's not, what was wrong with it? Was it lost? Was it misplaced? Was it broken? Then we try to capture those costs. So what we're trying to build is really a database of what that really does cost us when tools aren't in the right place, when they aren't ready to go.
Before they began lean tooling in their plant, Eaton's tools were disorganized and hard to find, and they had more tooling than they needed, including some outdated tools. The first step of the 5S program eliminated 21,000 drill bits and thousands of other tools, worth thousands of dollars. They were able to sell those tools or send them to other plants. For inserts alone, their backup storage in the tool crib went from 4 cabinets down to less than 1 cabinet. So Eaton now carries thousands of dollars less in tooling inventory. It also freed up a great deal of floor space. At the assembly cells, disorganized tooling added time to everyone's work. Kim DeForest, an Eaton trainer, was involved in developing a supermarket system for tooling.
A lot of the assembly tools were in various locations and you weren't sure what cabinet they were in, where they were located. We've since taken these central stores and put them in numerical order and identified all the tools and individual locations of the drawer so they're easier access.
Determining which tools were to remain in the cell and which ones were to be delivered only when needed was one of the first decisions to make.
Do you see that? Remember we talked about the 5S principles? The item is used every day, the item is used weekly, and the item is used occasionally. This is again, that's those same principles kicking in. I have a work cell. I cannot put all the tools that the work cell needs inside the cell. And sometimes the cost of the tool is so exorbitant that it has to be a shared resource and kept at a central location that can be accessed by all the cells. So again, you can see, you look at everything being utilized on the individual machines. It could be coolant, it could be lubricant, it could be rags, wrenches, whatever. And you say, well, what do I put on the machine? What do I put in a central storage within the cell? And what do I put in the tool crib? And that, what is put in the tool crib, has to be basically delivered by the water spider. Even the inserts that are being consumed, which are in the cell, you want to have that replenished by the tooling vendor. And again, there are ways to do that. The vending machines have made it absolutely feasible. It's an item of discussion that's way beyond this particular lecture. Let me continue.
With respect to the tooling, one of the things we face in our product line is that we have a high variety, okay, low volume, high mix to deal with. So it's important to design a system that allows you to have point of use for the things that you use all the time, but also it's very organized, so with those things that you need occasionally, you know right where to go, right where to find them, and bring them back.
After the exact tools were determined for each cell, a master list was created, and visual controls were used to maintain this standard.
One of the keys to our success is this label right here. It's a Brothers labeler, and it's as simple as you can have a label that we've used just like that. It comes out right here.
Eaton also uses tool boards to identify tools at point of use. A good example of lean tooling at Eaton is how their mandrel rods are stored. The ends of the mandrel rods used to be mixed in drawers, where they were hard to locate and sometimes broken. But now the rods are stored right at the machine. Now it only takes 30 seconds to find and place a new rod onto the machine. To further simplify tooling organization, each cell has been branded with a different color. Within the cell, all the tooling and carts follow the same color scheme. Eaton has taken lean tooling a step further with a technique known as hijunka, or leveling. To do this, Eaton had to ensure that jobs were scheduled at machines in a way that required the fewest changeovers.
People used to come in the office, and this is how they were. When I first came in here, they look through and they say, well, we want this one. I'll take this one and do it today. And let's see, I'll take this one here and do it today. They pick and choose. This way here.
Go back to something which we had discussed under theory of constraints. Remember that in the current state, when you do not have a schedule and you're doing something called push scheduling and you have a bottleneck machine, what does the operator do? He or she says, okay, I ran a particular job. My machine is already set up for this particular job. If you are doing push scheduling, you are putting too many jobs in front of him or her to choose from. So if you don't control the release of work into the system, you're giving them the opportunity to do exactly what this gentleman is saying, which is, let me pick something which will be run in the shortest amount of time. And that dispatching rule in scheduling literature is called SPT, shortest processing time. On the other hand, what you would like is earliest due date to be the basis on which they pick the jobs, or in more sophisticated cases called critical ratio rule. But again, what's the beauty of theory of constraints? If you don't push work into the shop, then when those jobs arrive at the bottleneck, you are not going to have too many jobs in queue to allow the operator to do what's convenient to them to show that they're efficient. You now are forcing them, especially if you have a linear queue and the water spider is delivering the parts in a certain sequence, you're forcing them to follow what the water spider knows as amenable to the best way to the production schedule. That's what's important.
There is no more of that.
Paperwork for each job is now filed by type and size of stock.
The person that works in this department comes in, looks at the orders, and like this one here is 1.5 inches. They'll put it in the 1.5 inch slot right here, and that way I can group them together. This one here happen to be the same size. I can run those two together, get rid of a setup. The next one happens to be the same thing. Another setup that I've eliminated. In fact, all of them are the same. So I eliminated 4 setups by putting those in one slot here, doing them all at the same time.
Eaton Aeroquip believes that lean tooling is a vital component to its lean manufacturing approach.
There's somewhat of a leap of faith involved in this whole thing, and I've been through it enough to know that you have to believe, and you have to drive it from the top. You will see the results, but you can't always quantify this stuff going into it because they aren't practices that we've normally done. It's like any other aspect of your business. It has to be organized, it has to be visually very easy to understand, and it has to be there when you need it.
K&A Machine and Tool, located in Jackson, Michigan, is a supplier of precision machined components primarily for the aerospace industry. K&A started using lean tooling when they realized that they couldn't achieve lean manufacturing without it. Carl Frid, owner and president, was leading the charge toward lean.
Today, we have to set jobs up 10 times faster than we ever used to. We have to be able to go from this job to that job in a matter of minutes rather than hours, due to the fact that we can't run the parts any quicker, but we can lose some time in our setup. So that's our key, is to reduce our setup time.
Tooling at K&A is triggered when the operations manager delivers the job file to the tool crib. The tool crib manager delivers the gauge list to the quality lab, selects the appropriate tooling using the tool sheet in the file, and creates a tooling kit for the job. While the tool crib manager is collecting necessary tools, the quality lab is collecting necessary gauges and incorporating them in the kit. The tool crib has a location for each cell's next 2 jobs and a spot for the returned tooling from the previous job on the cell. A tooling kit for each job is delivered by the tool crib to...
Again, I hate to remind you, but go back to the first couple of lectures in the class. Remember that little example we had done from the Groover textbook about the milling machine operator who went back and forth from his machine to the tool crib to get the tools? Today, there's actually an ERP system developed by machine shop owners. I think I mentioned it earlier, ProShop ERP. And the website is adiansystems.com. Let me know if you're interested. They basically have automated the entire setup process. The tooling, the gauge issues, everything has been automated where in the tool crib, they know exactly what needs to be prepared. In the inspection department, they know what needs to be prepared. And the water spider essentially goes like on a pick route and collects all these items and delivers them to a location on a rack at the particular machine. So all of this has been automated. That's today's enterprise resource planning system.
Each cell for the next job that the cell will perform. The operator simply has to pick it up without leaving his cell. Each cell is color-coded. In this case, cell F is blue. At the tool crib, there are racks to match each cell. Inside the crib, files are organized by cell and date, with the next job to be run on top. K&A uses a just-in-time pull system for tooling to make sure that they provide their cells with only what they need when they need it. When the operator needs those tools, they are available without searching, walking, or even asking. To let the tool crib know that the tooling was picked up, he raises the green flag. When the tool crib employee delivers the next job, the flag is lowered and old tools are collected.
Again, you might be thinking like, what is this? Are we celebrating Independence Day and putting up jhandas, and stuff? Well, this is, so many years ago. Today, it's a combination of the enterprise resource planning system, the manufacturing execution system, and the machine monitoring system. I don't know the details, and that's some of the recent work I'm beginning to do for my next book. But you can see over here that these signals which are being sent by the machine operator to say, hey, I need this support. It could be signals to maintenance. It could be signals to shipping. It could be signals to inspection. It could be signals to the operator. All of these today, in the era of IIoT, Industrial Internet of Things, they've pretty much been automated. So I think what you want to be doing again to increase your resume power is to ask, what is the technology out there? What's the smart manufacturing asset available out there that essentially automates some of these proven approaches which worked in the manual era, but now in the modern day aerospace or medical machining machine shop can surely be automated, if not already automated.
This system can save hours of unneeded walking, waiting, and searching for tools. K&A found that very few tools were actually needed at the point of use. They found that it was more efficient and less expensive to deliver most tools when they were needed.
We found our calibration system to be so enormous that we couldn't keep up with it. So we decided that it was time to reduce it. So we decided, we went out to all the guys and told them we would purchase all the tooling they had in their toolboxes, but the toolboxes had to go. They didn't like it when we were here to take the toolboxes out. But today there's none in the shop. We supply all the gauges for the cells. And our calibration system is about a third of what it used to be, or even a little less. Makes it easy on our quality people to keep up with it. We gained probably a whole cell by eliminating all the toolboxes that were in the shop.
The tooling in K&A's work crib is visually controlled so that it takes only a few minutes to gather the tools for a job. For example, perishable tools, such as drill bits or inserts, are matched with machine parts, such as holders for quick setup.
Okay, to further simplify everything, what I do is these numbers correspond with this drawer here. Say we need a 1 insert, a 1A, we would grab the insert, come over here to our drawer, and over here, number 1, we grab our holder, and the insert fits in the holder.
Kanban cards are an
Again, you've done flowcharts, correct? You've done flowcharts. So just imagine you could create a flowchart by merging the assembly sequences that this lady would show you, tell you, you know what, for this particular tooling assembly, this is how I would go and pick such and such clamp, such and such holder, such and such insert, right? So data science to the rescue again. What is a flowchart? A flowchart is a combination of multiple individual sequences, but what you have now is you have decision blocks. And so depending on the variation in the workflow, the decision block will send you to a different part of the flowchart. So if you could create the flowchart with your data analysis of these different assembly sequences, and you create a nice visual poster, anybody, even training or night shift, whatever, will have a standardized process for pulling together the various, items to create a tooling assembly. So once again, keep in mind, this may look manual, you may look at this and say, oh, it's so common sense, it's so hands-on. Trust me, in today's age, all of this can be doable and semi-computerized and visualized with data science and industrial engineering and operations research. So again, separate conversation, but if anybody's interested, give me a holler, and I'll be happy to talk to you during the rest of the week. Today is not the only day to teach you and talk to you, okay?
important part of K&A's lean tooling system because they control tooling levels in the plant.
Every insert has a card. Once we get low on the insert, we will take the card, put it in the to be ordered bin. Once the inserts come in, we will take the card back out of the on order bin, put it with the inserts in the appropriate bin.
But K&A is still searching for ways to be more efficient. Their next improvement is to install a vending machine for tooling inserts.
Aha!
The big advantage for us on that right off the top is when we purchase inserts today, we have to purchase a whole pack or 10 at a time. With the new system, we'll only have to purchase what we use on a monthly basis, one line item a month. So we'll be able to, an operator will be able to pull a CNMG or whatever it may be and use that insert. And as long as he's only using one, that's all he has to pay for. So it's one line item a month that we're going to have. Another advantage is we're going to be able to see which cells are using the most inserts. Just for instance, cell A may use a lot of CNMGs, and there may be a reason why that we're not seeing.
Knowing why one cell is using too much tooling may point out some unseen waste. K&A Machine and Tool believes that lean tooling must be brought to the shop floor through standardized work procedures. And those standards must always be examined to find new and better ways of doing things. Classic Turning, located in Jackson, Michigan, is a world-class supplier of precision machined components for the medical and aerospace industries. Classic has used lean tooling to drastically reduce changeover times on all of their machines. In their most complex cells, they have reduced changeover times from 5 hours to less than 75 minutes.
First thing we did was we sat down as a group and tried to figure out how to measure it. We found our worst cell. And the first thing we were looking at was how long it took to set up the cell. So we started measuring the times, and our times were 4.5, 5 hours.
For Classic, a half day of production lost on setup was a major problem. So the setup reduction team decided to use a support person to gather all tools and gauges for each cell. This keeps the machine operator from leaving the cell.
We start out with a tool data sheet. The tool data sheet should have all the gauges, work holdings, the tooling for each individual operation, the programs that were used for what operation and what machines were being used in the operation. It consists of the first stop tooling. It should match the tooling for the first stop on the tool data sheet. And we have each one usually labeled per operation. We have the second operation here, all the tooling that's involved with that. And we have the mill tooling, which is involved with the mill. Sometimes we get to the point where we actually have extra tooling. In case one breaks, we have extra right here in the job box. You don't have to go all the way across the shop. We have parts in here that are partially completed, so we could use this one for a setup. That way you could set up the second or the third op without having to wait for the first one to be completed first. We also have a complete part, so that way you do know what it looks like, just as a quick reference to know what it's going to look like.
Getting the tooling ready ahead of time has shortened the changeover times from 5 hours to 1. But sometimes problems do arise while you're
5 hours to 1. Go back again to theory of constraints. The step, exploit the constraint. What did Jonah tell Alex, the plant manager? How much of your 8-hour shift are you using to actually cut metal, right? In a machine shop, you're cutting metal. In a heat treatment furnace area, you are heat treating a part, right? In welding, you're depositing molten metal. That's the true value added portion. So when, Alex said, no, we might be losing, 2 hours per shift. Yes, yes. Every hour of lost capacity is an hour lost to the entire system, right? I mean, what he was basically saying was, look, you have to take the capacity which you're paying for but not using because you're wasting it on non-value added work and convert that to value adding time. Don't go in and pay overtime. Don't go in and buy new machines. Don't go in and hire people just because, accounting will see only those options as means of creating capacity. Once again, guess who would do all that nitty-gritty work? All of you industrial engineers.
for getting your tooling. And when they do, it's best to solve them before you shut down your machines.
No, we do not have it yet. It has not been turned in. We'll get it. Okay.
If this problem occurred while machines were down, more than 2 hours of production time would have been wasted. The support person's job is made easier through job boxes or toolkits, which are packaged and stored for repeat jobs. These kits are color-coded and stored in supermarket fashion at the cell.
What we have here is a job box that we prepare for special tooling. We keep these in a designated area, so the next time the job comes up, we can pull it off the shelf and hopefully have most of the tooling that we need for the job.
At Classic, every idea has come from the employee teams, not handed down from management. But the question is, how do you begin lean tooling?
It's just you have to set a focus, you have to try it, you have to put a goal out there to try it, and
May I add something here? You've probably, as this video ran, you saw a little caption in the bottom left corner which gave you the title/position of the individual who was speaking. You see, in most of these companies, at least because they are small, it was the president, the owner of the company, who was driving a lot of these changes. So it's not like he or she has all the time in the world to do the Kaizen, to kind of do the sweeping and the cleaning and the labeling, but they are leading the effort. So their subordinates know that there's going to be an accountability and so tell me what you've done till now kind of, sessions that each of them will have. So my experience has been, again, when I began working full-time in consulting and, I had to report to such people was, those engagements where I succeeded were where the boss man or the boss woman, the person who brought me in, really, really understood lean. They really understood job shop lean. They learned it from me. Now, forget about me. What I'm saying is, when I found that that individual, typically an industrial engineer or an operations person with lean background, said, I'm going to learn this stuff myself, and I'm going to basically then go out and practice it and teach it to my subordinates. That kind of engagement, that kind of leadership absolutely assures the success of lean implementation. But if you have the typical president who's like, let me go golfing, right? Let me go fishing. Let me go speed boating. And I'll, tell my plant manager, hey, here's the book, The Goal, read it, and let's do some TOC stuff. I was at a CEO meeting and some buddy of mine, my golf buddy, said great things about theory constraints. If that's the kind of leadership that's trying to implement Lean or Six Sigma or whatever you want to call it, forget it. It'll be a flavor of the week. So please understand, when you begin your careers, you will probably be reporting to somebody who heads up operations, right? You make sure that you do enough to convince him or her to work with you. Because if people, the people you're working with, if they see, top level support is not there for IE XYZ, they will blow you off. But if they understand that they better work with you because they will be held accountable to implement the projects that you are trying to work with them to implement, poof, good things will happen. And at a certain point, those naysayers will start seeing that you have a good heart, but also that you have the backing of the head honcho. Once that happens, trust me, Lean will become almost a way of life. And I say it because I've seen it. Because every place I've gone into, I've always been resented. Okay? But I won over people, and the people I won the most over were the employees. But again, I'll be very honest with you. At a certain point, Lean is going to start exposing the skeletons in the closet of the people at the top. And unless they have the humility to change their ways and support Lean thinking, people like me will get kicked out. And people like you might get kicked out. So, always, it's important as an industrial engineer that change is hard sometimes to implement.
We just wouldn't go back.
The experience of these companies reveals 5 keys for Lean tooling success. The first key is management commitment. Managers must set the goals, provide the resources, and stay involved. Next is employee involvement. Employees are closest to the facts, and they are the ones who have to implement Lean tooling every day. The 5S system is an integral part of Lean tooling. Not only does it allow you to prepare for far-reaching changes, it will help you sustain those improvements. Standard procedures for tooling activities are clearly an important aspect of Lean tooling, and something that is often neglected. However, standards are useless unless people will adhere to those standards. And this is where visual controls play an important role. Remember that the purpose of Lean tooling is to immediately cut costs, reduce production lead time, and ensure a quality product.
So why do Lean tooling? It's because it's an important part of your manufacturing system. And if you do all the other things right, and I've been involved in projects where we've done that. We've done every other thing right, and we found out, wow, why can't we get the production we need? Why can't we get the throughput? Well, because we got people wandering all over the place looking for the tools they need. So it's an important component. You got to have it. It's like anything other aspect of Lean that's often overlooked.
So again, hats off to Society of Manufacturing Engineers. They teamed with this group of Lean consultants and machine shops. And I found these 2 videos to be just wonderful. Okay, they're a little bit dated. And yes, but personally what I feel is that all that's needed is take those principles and essentially adapt them for today when you have the industrial Internet of Things, mobile communications, RFID chips to track usage and conditions of tools. It's amazing what is possible today. But unless you have this higher view of value stream maps, work cells, throughput improvement, cost reduction, you will not be in a very good position to understand, so where do I make the improvements and how much technology do I incorporate to make the improvements? That is going to come with time. But as always, videotape the operation of a machine, videotape the operation of a cell, videotape the workflow, the physical workflow of a part number being sent to the machine shop. That's your starting point. Start to finish. Break up the flow into value-added time, non-value-added time, Pareto the non-value-added time, find the categories which are the biggest contributors to non-value-added time, and poof, 5 whys, 5 hows, Gantt charts, cost reduction templates, go with it, okay? Any questions? I'm happy to take questions if people are still awake, that is. Sorry guys, but I know that this is hard, but send me some questions. If not, I will shut down this lecture, and like before, I will convert it to a video and post it on Blackboard, and I'll also make it available on my Vimeo website. So that way, you know, what I'm hoping is that these organizations whose videos I use and embellish, I'm basically going to say, look, I'm using it to educate and teach my students, but it's a free source. This lecture is, you know, amenable or accessible to any of your members. In return, please allow me to use that for teaching. And I'm not going to sell this recording. So if I don't hear from you, I'm going to consider the class over. Anybody would like to ask me questions? Thank you guys for attending. I see about 15 students listed. Good for you. I'm happy you could attend. Please, you know, again, you're not limited to interacting with me during these hours only. If an individual or a team wants to discuss a special topic, I will check with the department. I will check if there are certain time slots during the week, not necessarily Friday, when I can go ahead and schedule a Zoom meeting. I'll basically invite that select group of students to the meeting, and you know, we can discuss whatever you want. So I have one team which sent me their project presentation. This is Jason, Avesh, and Mohanish. It's a pretty good job. And in their email, they said, please don't be critical. And I'm like, no, I'm going to praise you. So the way I would work with them is I'll schedule a meeting, fire up their PowerPoint, and then talk them through my comments on each one of the slides. That's how we work. So if I don't hear from you, I don't see any chat, hands raised, or anything. I'm going to stop recording, and I will talk to you again next week. Next Friday, my plan is either to discuss the goal video or to discuss the customer-focused cellular manufacturing video. After that, I would like to discuss a couple of videos. One of them is a value stream mapping case study, and another video is which describes all sorts of Kanban systems. So that's my basic plan, that I want to go back and revisit topics where I felt the lectures, I did not do them very well, or I felt that the students should, you know, be told these concepts again so that it remains with them. So that's basically the plan. Please, again, keep in touch. Stay safe, guys, okay? And don't lose heart. Keep your chin up. All of us are going through a very bad patch, but like they say, there is going to be light at the end of the tunnel. Okay? God bless. Have a good weekend. And don't eat too much and don't drink too much. And if you drink too much, just drink water. Bye-bye.